Welcome to the third and final video of the PrairieLearn Pico Emulator series. This is the next step video by SDMA 24-33. If you have not viewed the overview and configuration videos, we highly recommend viewing them before continuing with this video. In this video, we will go over the next steps for implementation of the microcontroller emulator, which files need to be modified to do so, and some more ideas for innovation of what can be done. First, we want to talk about the next steps. The next steps needed for the emulator is to integrate the microcontroller into PrairieLearn's environment. The QEMU emulator that has already been developed as well alongside this emulator may do this already, and this emulator that we're using here for the Pico was designed to test its viability separately. Which emulator is used largely will depend on their implementation as well as the goal of the group and Dr. Jones. Please talk with your advisor/client, Dr. Jones, for more information as to what emulator to use and how it will be used for his vision. Finally, the biggest thing to be done with this is the comparing of outputs. As we saw in the previous videos, the outputs of code run on the emulator are either printed to the console or a text file depending on what configuration is used with the script or done manually. This is done, for example, as we saw, is the user generating the code and then executing the script. That simulates what the student would do, would be submitting their answers, and their code is then executed. The code that is the correct answers should then also be generated, and whether that is randomly or predetermined, and its output should be compared, whether that is the final output, the values of the registers, or whatever it may be. Those values need to be compared in order to give proper grading for a question. So what files to modify? There are two main files that we want to look into. Obviously, we are using the buildhexfiles.c file to have the C code. However, the addressmap.h file may be modified but is recommended against, and the uartmap288.h is a new substitute file we created and is the recommended one to be modified. We will go in depth right now and show what can be done with these files. Going back into our Linux VM, right now we have the addressmap.h file open. This can be found at the following path: SDMA33, emulator, Pico SDK, source, RP2040, hardware regs, include hardware regs. For the actual file path, you can also see our documentation written for the information. That documentation can be found in the description on our team's official website as well as in the Git repository. Going down, we can find our UART modifications that we attempted. The commented out code is what was attempted by the current team. We originally attempted to modify the register values to have the same values as the TM microcontroller instead of the Pico. When doing this, we ran into many issues and decided to go against this. Instead, we made the file uartmap288.h. This can be found in SDMA33, emulator, Pico SDK, source, common, Pico standard library, include Pico. Once again, this can be found in the documentation if you would like a better look at it. In here, we took a subsection of the Pico input registers for the UART. These are the base addresses for the UART, and as you can see, they are all the same for UART 0 and all the same for UART 1. This is because elsewhere, if you would like to see the written documentation on configuring from scratch, you will see that every single register name has its appropriate offset configured in other files. We will not be going into that as those are preset and everything needed has been completed already. This is for UART 0 and UART 1. This code can be found at the following link, which we will show in the slides coming up soon here. And you can scroll down and find everything for the 288 microcontroller class. We used the UART 0 and 1 and replaced their values. Instead of being the offset values from the base, we replaced them with the base values as said before. This file is the one we recommend you to modify. Adding in things underneath this, such as UART2 as an example, will go in here and add additional functionality to the program. As seen on this slide, we can go through what our team's ideas are. Jumping to the last bullet point quickly, we can see that the link to the site shown earlier is here. This is where we recommend you getting any code and discussing with Dr. Jones as to what needs to be implemented. Our team's ideas for moving forward for next year's team in fall of 2024 would be to implement GPIO timers and any other functionality seen needed by Dr. Jones. GPIO is the next step logically after UART. Additionally, you can implement additional UARTs such as UART2. However, the original Pico emulator does not have anything further than UART1, so this may require further implementation. As we stated earlier, the main goal of this emulator would be to use it with the questions in the PrairieLearn homework assignments. However, the direction this emulator is taken is up to the new senior design team and Dr. Jones to address. Thank you.